using a calculator or otherwise, evaluate each of the following. So of course, question 1, you can plug these values as they are straight into your calculator, and we should end up with 24.33 to 2 decimal places. So part 2 again, this is equal to 2.68 to 2 decimal places, and of course we are told we can use our calculator. So Jenny works at Sammy's restaurant and is paid according to the rates in the following table. Her weekly wage agreement is 600, as we can see in the equation here, in the formula here for W subscript J, which represents Jenny's weekly wage. Our weekly wage for Jenny is 600, which is the basic wage, plus 0.9 times the number of customers. So N represents the number of customers. So we're asked to determine Jenny's weekly wage if she served 230 customers. So weekly wage for Jenny will be 600, that's her basic, plus 0.9 times the amount of customers served, which is 230. And this works out to be, let's use a calculator and do this problem. So 600 plus 0.9 times 230, we get 807, which means Jenny's weekly wage would be $807. In a good week, Jenny's weekly wage is 1,000 or more. What is the least number of customers that Jenny must serve in order to have a good week? Alright, so in a good week, Jenny's weekly wage is equal to or more than $1,000. And remember her weekly wage, what was her weekly wage again? 600 plus 0.9 N. So replace WJ with that, and we're told it's more than 1,000, more than or equal to. So we solve, we can subtract 600 from both sides. So if we subtract 600 from both sides, we are left with 0.9 N greater than or equal to 400. Divide both sides by 0.9. We end up with N equal to N more than or equal to 400 divided by 0.9, which is 444.44. So remember, we're talking about N represent the number of customers. So we're talking about number of persons. And the number of persons cannot be in decimals, right? Number of persons would have to be some natural number, of course. So the least number of persons, or least number of customers that she must serve would be 445. So you round up, because it's not possible to have decimals when you talk about number of persons, right? So our solution would be 445 customers that she must serve if her salary should be 1,000 or more. At the same restaurant, Shauna is paid a weekly wage of $270 plus $1.50 for each customer she serves. If WS represents Shauna's weekly wage, write a formula for calculating Shauna's weekly wage when she serves M amount of customers. So Shauna's weekly wage formula will be 270. That's a flat rate, flat weekly rate, plus 1.5 or $1.50 per customer, so 1.50 times where the number of customers called M, so 1.5 M. So that would be the formula for Shauna's weekly wage, where M represents the number of customers she served. In a certain week, Jenny and Shauna received the same wage for serving the same number of customers. How many customers did each serve? So we are told that Jenny's wage, which was WJ, equal to Shauna's wage, W subscript S, in a particular week. They are told these both wages are the same. Now, what was Jenny's wage? Recall that Jenny's wage was 600 plus 0.9 N, and Shauna's weekly wage 270 plus 1.5 M. Now, we are told that they serve the same number of customers. The number of customers for Jenny, we represent it as N. The number of customers for Shauna, represented as M. So we are told that we know that N is equal to M. Alright? So in this formula, of course, we could use this equation. Of course, we could use N for both, since they serve the same amount. So whatever the value of M is, the value of N is also the same thing. So this M, we can replace it with N, since they are supposed to be the same value. They serve the same number of customers. And of course, we can solve now. We can group. Let's group the N. Let me group the N over the right hand side. So I have 1.5 N, which means I have 0.9 N here. I'll group the constants over here. So I have 600, and I have minus 270. So we subtract, like we subtract 270 from both sides, and we subtract 0.9 N also from both sides. So we end up with 1.5 minus 0.9, that's what, 0.6 N, and 600 minus 270, that's what, 330. So we divide both sides by 0.6, since we're solving for N. Divide both sides by the same value. Right, so 330 divided by 0.6 is equal to 550. So they serve the same number of customers, which amounts to 550 customers. Which means we can indicate here that both Jenny and Shauna served 550 customers. Question 2, part A. So factorize completely each of the following expressions. So we should be able to recognize that this expression here is a difference of 2 squares. So 1, we can rewrite 1 as 1 square. And 4/8 square, we can rewrite this as 2h all square. Which means, alright, so 1 minus 2h, 1 plus 2h. And of course, it does not matter which bracket you put first. Alright, so if you wish, you could write it as 1 plus 2h, 1 minus 2h. It doesn't really matter the order. Remember, multiplication is commutative, hence order is not important. Also, we are also factorize this expression. So I guess we can factor by grouping. So the first group, notice for PQ minus Q square, we can factor out Q as the highest common factor. So we factor out Q. To get the terms of the bracket, of course, we can always divide each of these terms by the highest common factor. So PQ divided by Q will be left with P minus Q square divided by Q, that would be Q, right? In the other group, other pair, minus 3P plus 3P, of course we can factor minus 3, since the expression minus 3, well, since the expression begins with a negative term, we can factor out a negative term here. So the highest common factor here we have as minus 3, so we divide each of these terms by minus 3, just to get which terms we put in the bracket. So minus 3 into itself, positive 1, so positive 1P, and then 3 divided by minus 3, that's minus 1, so minus 1Q, so it's minus Q. And of course, here we have a common factor, P minus Q, common bracket there, factor, and we're left with positive Q minus 3. And again, it doesn't matter the order, you could put Q minus 3, P minus Q, order not important. So we are now at 2B, so we have an equation here, 3 over 2y is equal to 12, and of course, to get rid of the denominator, we can times both sides by 2. So the right hand side, 12 times 2, that's 24. And here, by 2, 2 into 2, that's 1, so we're left with 3y. Alright, divide both sides by 3. Alright, so y equal 24 divided by 3, which is equal to 8. So next we're asked to solve a quadratic equation here. Now I'm going to be using two different methods. Alright, over here I'll be using formula, and over here I'll be using factorization. And of course we can solve this method, we can solve this equation also using completing the square method, but I'll be just using formula and factorization here. So using the formula x equal minus b plus or minus square root b square minus 4ac all upon 2a, which means that making substitution, of course, so where a is a coefficient of the x square, which is 2, b is a coefficient of the x, which is 5, and the constant c there is negative 3. So let's plug them into this equation now. So negative b, so negative 5, right? Plus or minus the square root of b square, which will be 5 square, which will be 25. B is 5, right? So okay, so b is 5. Sorry, b is 5. So b square would be 5 square. That's how I get the 25. Now negative 4ac is negative 4 times a, what's the value of a? 2, times c, what's the value of c? Minus 3, right? All upon 2a. The value of a is 2, so 2a is 2 times 2. Let's continue. So x would be minus 5 plus or minus the square root of 25. And we have now minus 4 times 2 times minus 3. That works out to be what now? 4 times 2 minus 4 times 2, that's minus 8. Minus 8 times minus 3, that's positive 24. All upon 2a. 2a, so 2 times 2, that's 4. So now x would be minus 5 plus or minus the square root of 49 over 4. So x equal to minus 5 plus or minus 7, because square root of 49 is 7, right? All over 4. Which means that x is equal to minus 5 plus 7 over 4, or x equal to minus 5 minus 7 over 4, which means x is equal to, now minus 5 plus 7, that minus 5 plus 7, that's 2, so 2 over 4, or a half, right? If you want to simplify that fraction. Or the other value, minus 5 minus 7, that's negative 12 over 4, and negative 12 divided by 4, that's negative 3. So our solutions are x equal to a half or x equal to negative 3. Now let's solve now using factorization. Let me just make a space here. So this was, let me just rewrite the equation, 2x squared plus 5x minus 3 equal to 0. So of course you want to rewrite the 5x. Now here AC, that's 2 times minus 3, that's minus 6. So we write down all the numbers that multiply to give minus 6. That's 2 times 3, of course, and 1 times 6. These are the factors of 6. 2 times 3, 1 times 6. Now the pair we select, when you add or subtract that pair of numbers, you should end up with positive 5. And when you multiply these numbers, you must end up with AC, which is negative 6. So of course, the pair we select is 6 and negative 1. Because these two numbers have a product, the same product of AC, which is negative 6. And when you add these two numbers, of course, we get positive 5. So it's all about rewriting the 5x. Let me just... So we're going to rewrite the 5x using 6 and negative 1. So 2x squared plus 6x minus 1x, and note it's still 5x, because 5x, 6x minus 1x, still 5x minus 3. But we use these numbers because, of course, these numbers, when I multiply 6 times minus 1, we get the same value as when I multiply 2 times minus 3, which is minus 6. Alright, so we factor by groups. So for the first group, the common factor here is 2x. So we factor out 2x, and here we have x plus 3. And here we factor out minus 1, and of course x plus 3 again. And after we factor out the 2x to get what we put in the bracket, of course we can just use a different color. Of course you can divide each of these terms by the highest common factor, just to help you with the terms for the bracket. And in this case, we factor out minus 1 in the second group, so of course you divide each term by minus 1. And this is to help you for the terms of the bracket. So minus 3 divided by minus 1, positive 3. Minus 1 into minus 1, that's positive 1, so hence 1x. Same here, 2 into 2, that's 1. X squared divided by x, positive x here. X into x1, 2 into 6, 3, and we have positive 3 here for the bracket. So that's just to help you with the terms for the bracket. And of course, now we have a common factor, x plus 3, and outside the brackets we have 2x minus 1. And to solve with this method, we equate both brackets to 0. So we have x plus 3 equal to 0, or 2x minus 1 equal to 0. And we solve each equation, subtract 3 from both sides, x equal to minus 3. Here, add 1 to both sides. We get that. Divide both sides by 2, x equal to a half. So we get the same solution with the factorization methods as we did with the formula. So we are now at 2c. The quantities f, m, u, v are related according to the formula. So f, very famous formula in physics, f is for force, m is for mass, v for final velocity, u for initial velocity, t for time taken. Alright, so we have given some values here, so we make direct substitution. So m is 3, so replace m with 3. V, what's the value of v? 2 minus u. Now u is negative 1. So careful there, u is negative 1. All over t, and we're told t is 1. So hence f would be equal to 3, and the bracket is also 3. 2 minus minus 1 becomes 2 plus 1. So f would be equal to positive 9. So now we're asked to make v the subject of the formula. Remember the formula was f equal to m into v minus u over t. Alright, so we're asked to make v the subject of the formula. Let's do that. So of course we want to get rid of the denominator t here. So we can times both sides by t. So t times the left hand side and t times the other side. Alright, so t times f, that's tf or ft. Doesn't matter the order. And t into itself here, 1. Alright, 1. So we have m into v minus u. So now we can distribute the m, or clear the bracket there on the right hand side. So m times v, that's mv, and m times minus u, that's minus mu. Remember we are transposing for v, so what we could do is add mu to both sides. So we'd have ft plus mu. So we're adding mu to both sides. So mu plus the left hand side. Mu. Add mu to the right hand side. What happens now? These will cancel, right? Negative mu plus mu, that's 0. So we're just left with mv. Remember we're asked to transpose for v, so we want v by itself. So we can get rid of the m by dividing both sides by m. That's our solution. So therefore ft plus mu over m is equal to v. So our next question is a construction questions. Construct a triangle ABC such that AB, of course, when you draw the line AB, the length of AB is 8 centimeters, so that's 0 to 8, right? So A, B, and use your ruler and ensure that this length is 8 centimeters. So you start from 0 and you end at 8 on your ruler. We're told that angle A, this angle is 30 degrees. So this angle is 30 degrees. So how do we construct a 30 degrees angle now? First, you have to construct a 60 degrees and bisect it. So you first have to construct 60 degrees. So compass needle on A, and you swing a semicircular arc, something like that. Then where the arc cuts the line here, your compass needle here, you swing another one to cut the first arc, and you use your ruler and your pencil, and you connect, and this angle is 60 degrees. This angle between this line, but what you actually want is a 30 degree angle, which means you have to bisect the 60. Well, here's how we bisect the 60 degree now. So at this point here, your compass needle here, you swing an arc, compass needle here, and you swing another arc. And then where the arcs intersect, you use a ruler and a pencil, and from point A, this intersection is 30 degrees. Alright, we are told, though this line running from A will be AC. So when I measure on this line, it should be 10 centimeters. So when I measure this line, of course, it should be 10 centimeters. Alright, so just giving you a guide here, you will do it on your own. And then 10 centimeters. And of course, you use a ruler and a pencil, and you connect B to C. And there you have your triangle. Part B. Diagram shows the triangle OPQ. Let me just show you what triangle OPQ is. There's a triangle OPQ. On part A, we are asked to state the coordinates of Q, which will be this Q is here. So notice the x coordinate is 4, and the y coordinate, of course, you go up 1 vertically, right? So the y coordinate would be 1. Next, we are told that the line PQ is mapped onto an image line there, PQ prime, by an enlargement with center from the origin, that's O, and a scale factor of 3. On the diagram above, draw the line PQ, or image of PQ. So the center is 0, 0, scale factor of 3, which simply means that to get the new coordinates of this triangle, you'll multiply all the coordinates by 3. Alright? So let's draw the line P image Q image. Scale factor 3, bear that in mind. Center origin, scale factor 3. Alright, so let's draw PQ now. So notice Q was a point 41, or this point was 41, right? 41. So the scale, multiply this by 3, we get 12, 3, right? So the new Q image will be 12, 3. That's Q image. And how we get this point 12, 3? We simply multiply 41 by the scale factor of 3, so we get 12, 3. And P was 2, 2. This point 2P was 2, 2. So you multiply by 3, we get 6, 6. So P image will be 6, 6. It's P image 6, 6. And you simply use a ruler of course, and you connect P to Q. Alright, and you have a line P image, Q image, right? And of course, you'll use a ruler for that, not like me doing freehand there. Alright? So next, we are told that the triangle OPQ undergoes a reflection in the line y equals 0 to produce the image OPQ, double prime, of course. So on the diagram above, draw this new triangle. So, triangle OPQ undergoes a reflection in this line. Now, this line y equals 0, it's very important to note that the line y equals 0 is actually the x-axis. So it can read the triangle OPQ undergoes a reflection in the line in the x-axis to produce this triangle, which is what we are being now asked to draw. So let's reflect the triangle OPQ in the x-axis and draw our new triangle. Here's our triangle OPQ. Let's reflect it in the x-axis. So the x-axis now will behave as what we call a mirror line. Alright, so we're going to reflect each point. So Q, how far is Q from the x-axis vertically? It's 1 unit away. So on the other side, it's 1 unit away also. So here would be Q, we're called double prime here. P, how far is P from the x-axis vertically? It's 2 units above. So your reflection would take it 2 units below. And here, how far is 0? Alright, no unit, it's actually there, so it stayed there. So O, so this would be right here. Alright, same point. And of course, use a ruler and you connect your 3 points, and you have your reflection in the line y equals 0, which is the same as the x-axis. So that would be your solution. So question 4a, the function f with domain a, a set of values 1, 2, and 3, just mean that those are the possible domain, those are the possible x values, right? So f of x is half x minus 3. What's the value of f of 1? So f of 1 simply means that you replace the x value with 1, so half of x becomes half of 1 minus 3. So what you have is half minus 3. What's the value of half minus 3? That's minus 2.5, right? It's minus 2.5, or you could say minus 5 over 2. Next, find the value of x for which f of x is equal to minus 2. Remember, f of x is half x minus 3, right? So we equate it to minus 2. Solving for x, we can add 3 to both sides, right? So this would become 0. So what we have is half x is equal to negative 2 plus 3, that's positive 1. And of course, we can multiply both sides by 2 now. So 2 times half, that's 1. So 1x, or x, is equal to 2. Part 3, an ordered pair for the function is expressed in the form AB, using your answers to part A1 and part A2 or otherwise. List the ordered pairs for the function f. So remember, the domain for the function was 1, 2, and 3. So we're told that at the top of the question. So domain are all the possible x values. So the y values, remember we found f of 1 to be, by the way, remember f of x was half x minus 3, right? And we found f of 1 to be half minus 3, which was equal to minus 2.5, right? Or minus 5 over 2. F of 2 was half x, so remember this is a function, half would be half of 2 minus 3. Now half of 2 is 1. 1 minus 3, that's negative 2, right? And f of 3, so we substitute all the possible x values, all the values in the domain. So f of 3 will be half of x, so that's half of 3 minus 3, which would be equal to half of 3 is 3 over 2, which is 1.5. So 1.5 minus 3, that's negative 1.5, or we say negative 3 over 2. So the list of, so the ordered pairs are done. Ordered pairs. Are the pair of x and y values. So ordered pairs are, so when x is 1, the corresponding y value or we say f of x was negative 5 over 2, or negative 2.5 if you prefer. When x was 2, the corresponding value was minus 2. And when x was 3, the corresponding value was negative 3 over 2, or negative 1.5. Explain why f of x is not equal to 5 for the function on page 13. Remember, the function was, let me just rewrite the function. The function was half x minus 3. And we're told that f of x cannot be equal to 5. Let's see what happens when x is equal to 5. So, if x is 5, let f of x be 5. So I'm going to replace f of x with 5 and see what happens. I can solve this by adding 3 to both sides. So I end up with 5 plus 3 equal to half x. And then to get rid of the half, I can times both sides by 2. So times once this side by 2 times this side by 2. You'll recognize that the left hand side is really 8. So 2 times 8, that's 16. And then 2 times half, that's 1. So 1x. So 2 times half x is 1x. So notice when the x value is, when f of x is 5, we have x is equal to 16. Now if you remember, the domain was 1 to 1, 3. So 16 is not in the domain. Is not in the domain, right? X equals 16 is not a part of the domain, which means that f of x cannot be equal to 5. Alright? Because for f of x to be equal to 5, x would have to be 16. Notice if x is 16, half of 16, that's 8. 8 minus 3, 5. Alright? But so therefore f of x cannot be 5. Because 16 is not a part of the domain. So that's our solution. Part B. So in part B, we are given a pair of inequalities. So I guess we can add one to both sides. Alright, so what that means here now? So we end up with just 3x on the left hand side, and 11 plus 1, which is 12. Divide both sides by 3. So x is less than positive 4. Next problem here, we can add 1 to both sides. So 2 plus 1 is less than or equal to 3x minus 1 plus 1. So this becomes 0, right? So we end up with 3 less than or equal to 3x. Divide both sides by 3. So 1 is less than or equal to x, or we could rewrite it with the x at the front. X is greater than or equal to 1. Is another way of writing the same statement. Represent the solution. 3x minus 1 is less than or equal to 11. Recall this is the equation we solved earlier. This inequality we solved earlier, and we also solved the inequality. 3x minus 1 is greater than or equal to positive 2. And what our solutions were? X is greater than or equal to 1. So we use a full dot here. Greater than or equal to 1. And remember the other solution, x was less than 4. So we use a little open. Alright. So this would be your solution. Set representing a number line. Alright. So more than or equal to, we use a full dot. And for less than, we use the open circle. Or equal to the full dot. So let's move on. So students in a group were asked to name their favorite sport. Their responses are shown on the pie chart below. And then we're asked to find the value of x, first step. So X degrees represent those for football, those who like football. So the value of X, notice, remember that the sum of the angles in a circle, that's 360 degrees. Alright, so which means the value of X would be 360 minus these other angles, right? So minus 94 minus 45. So X would be 221. Alright, so 221 degrees for football. And should add it with 94 and 45. We are supposed to get 360. So we can always just check that back. Next, we were asked what percentage of the students chose cricket. Now let's look back at what the percentage, the amount of angles for cricket was. Cricket, that was 94 degrees. 94 degrees, so we're asked what percentage. So we should convert the amount of degrees to percentage. And of course, solution for this, 94 degrees, and it's 94 degrees out of 360, right? 94 degrees out of the total, which was 360. And we're talking about percentage, so we times this by 100. And we end up with, let me just get my calculator here. So 94 divide 360 times 100. This seems to be, if I'm using one decimal point, it's 26.1%. And of course, that's the one decimal place. Or if you want it to be two decimal places, it will be 26.11. Next, given that 40 students choose tennis, calculate the total number of students in the group. So let's revisit and see what the amount of degrees for tennis was. So you'll notice the amount of degrees for tennis was 45 degrees. 45 degrees, that's about a quarter of the circle, right? No, less than quarter. So 45 degrees for tennis. That's about one eighth of the circle. Let's go back to the question. Alright, so remember, for tennis we had 45 degrees, right? So what we can do is let n represent the total number of students, right? So let's n represent the total number of students. Remember that 45 degrees. So 45 degrees, and then remember the total is 360 in terms of, so this is a fraction of the amount that chose tennis. So this fraction times the total, we should get 40 students, right? And of course, 45 over 360, that's 1/8. So 1/8 of the total came to 40 students. Good, so if we times both sides by 8, 8 times 1/8, that's 1. So that's the 1n, which is n. And 40 times 8, that's 320 students. So in other words, the total number of students in the group is 320. Next, the diagram below shows a frequency polygon of the number of goals scored by a football team in 25 games. Alright, so notice on the vertical axis we have number of matches, and on the horizontal axis we have number of goals. So we are asked to copy and complete this table, number of matches versus number of goals. So number of goals 2. So when the number of goals 2, how many matches go up? The point there is 3, go across. So when number of goals is 2, the number of matches is 3, right? And when number of goals are 5, number of matches here corresponding 2, so 2. So that's our table. Next part, we're asked to calculate the modal number of goals scored by the team. Now, remember there were 25 matches. So the middle number, you can add 1 to 25, you get 26 divided by 2, you end up with 13. Alright, so the modal value will fall in the 13th match. Notice 5 matches, then 7, that's 12. So the 13th matches would be here, and what's the corresponding number of goals 2. The other way to get it is to, okay, it's a longer way. So in 5 matches, you have a score of 0. So 5 zeros, 1, 2, 3, 4, 5. In 7 matches, you have the 1. So 1, 2, 3, 4, 5, 6, 7. In 3 matches, you have 3. So 3, 3, 3. In 4 matches, you had 4. So 1, 2, 3, 4. In 2 matches, you had 5, 5, 5. And in 1 match, you had 6 goals. So it's 25 numbers. And the median number would be the 13th number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Hold on, leave out a 2. Remember, okay, so 5 matches, so 5 zeros, 7 ones, 3 twos. Okay, I'll leave out the 3 twos. Alright, let me just insert the 3 twos there. So again, the median value would be the 13th value, because since it's 25 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this number would be your middle number. Alright. Oh, so we're not asked for the median, we're asked for the mode. Oh, so the modal number of goals scored by the team, the modal number of goals will be 1, alright, because we will 1. Alright, because 1 goal was scored in 7 matches. Alright, so the value here is 1. So what I was doing previously was answering this question. Remember, mode means the number occurring most often. So the amount of goals scored most often was 1 goal, right? That happened in 7 matches. So the median, we just answered that question above. The median number of goals would be 2. And the mean number of goals now scored by the team. So we would add all the values and divide by 25. Alright, so we can go about the mean in 2 ways. We can use the formula mean equals sum of fx over sum of f, or n the total. And of course the total was we're talking about 25 values, and add all the values. So add all of those values. Let me just add all of these values and see what we get. So it would be 0 plus 7 ones, so 7, plus there were 3 twos, that's 6, plus there were 3 threes, that's 9, plus there were 4 fours, that's 16, plus 2 5, that's 10, plus 6, so a total of 54. So this will be 54, the total is 54. So 54 divide by 25, we end up with 2.16 goals. So the mean number of goals. So on average 2.16 goals per match. So we are now at question 6, which is a measurement question. And in this question we are told to use pi to be 22/7. So the diagram, not drawn to scale of course, shows a cross section of a circular metal disc with radius 21 millimeters, as we can see here. So this is R, the radius is 21 millimeters. Alright, and a square hole with side 6 millimeters located at the center of the disc. And of course, a square, so this here is also 6, right? So here's 6, here's 6. Alright, so we are also calculate the circumference. So the formula for circumference is C equal to pi r. So C equal 2 times, and we are told to use pi to be 22/7. And r is the radius. The radius is 21 millimeters. So 21. So we can do some calculation here. 7 into itself 1, 7 into 21, that's 3. So we end up with 2 times 22 times 3, which is equal to 132 millimeters. Next, we were asked to find the area of the cross section of the disk. And of course, area is pi r square. Now, something that we have to be mindful of though when we're calculating the area. Remember, we have to subtract this square part, alright? So the area, so we find the area of a circle, and of course we subtract the square this here, because it would not be a part. This section here, that's shaded, this would not be a part of the disk, as there's an empty space there. So the area equal to area of the cross section equal to the area of the circle minus the area of the square, right? So the area of the circle, that's pi r square, and the area of a square, that's the area pi r square. Minus length square, and of course pi is 22 over 7. What was radius again? 20. Radius was 21, so 21 square. Minus, I remember the length of the side of a square was 6, so minus 6 square. So working this out, we end up with the calculator here. So 21 times 21 times 22 equal divide by 7. So this is 1386 minus 36. So it will be 1350. Alright, square millimeters. Alright. Given that the thickness of the disk is 2 millimeters, calculate the maximum number of disks that can be constructed from a 1000 cm cube of available metal. So we need to find the volume. We need to find the volume of the disk here. So the volume of disk would be, remember, volume would be cross-sectional area times the height, or in this case thickness. Alright, so cross-section was at 1350, and the disk would be 2 millimeters. So 1350 times 2 times 1, that's 2. 2 times 350, that's 700. So 2700 millimeter cube would be the volume of the disk. Now the volume of the available metal, the volume of metal available, we are told is 1000 cm cube. But notice the volume of this is in millimeters. So we want to convert the 1000 cm cube into millimeters, and we are told that 1 cm cube, is 1000 millimeter cube. So 1000 cm cube would be, so if I multiply both, I just simply multiply both sides by 1000. Alright? So 1000 cm cube, so 1000 times 1, so I multiply 1000 times the right hand side, will be 1000 times 1000, which is a million, right? Millimeter cube. So the volume of available metal would be 1,000,000 millimeter cube. So therefore, the maximum number of this required maximum amount of discs required would be equal to the volume of metal available over the volume of a disk. So the 1 million divided by 2,700, which will give us, let's get my calculator, which will give us 370.4 if we round it. Alright, but we'll talk about the maximum. Would definitely be equal to 370. So we round down. Remember, the number of this cannot be in decimals, right? So a globe is a scaled circle representation of the Earth. The actual length of the equator is 40,000 kilometers and is represented on the globe by a piece of string of length 160 centimeters. So it's a scale problem. So let me put here, so string length. So string length versus actual distance or actual length. So a string length of 160 centimeters represents 40,000 kilometers. So we can divide both sides by 160. If I divide both sides by 160, 160 divided by 160, that's 1. So a 1 centimeter string would represent 40,000. So 40,000 divided by 160. 250 kilometers. Alright, so that's very important. So we are told that 160 cm represents 40,000 kilometers, which means if we divide both sides by 160, 1 cm is 250 kilometers, 250 kilometers. So what length of string would represent the actual distance of 500? Now, to get this actual distance, so I have actual over the right hand side. To get this actual by 500, we could be 500. We can multiply 250 by 2. Multiply both sides by 2, so you get 500 kilometers here. So here, let us put here. Here we divide it by 160, both sides. And here, so we times by 2 because we want the actual to be 500 kilometers. So we times over here by 2 also. So the answer would be 2 centimeters. So 2 centimeters on the string. The actual distance is 500 kilometers. So the distance between P and Q is represented on the globe by a string of length 25 centimeters. Now remember, let's go back to the scale. Remember what the scale was? We worked out for 1 centimeter piece of string. The actual distance was 250 kilometers. Based on the information that we were given. So this would be the actual scale, right? So we are asked now to calculate the value of PQ in actual distance in kilometer. We are told that PQ on the string is 25 centimeter. So if I want 25 centimeter on the string, I multiply both sides by 25. So times both sides by 25. Right? So 25 times 1 centimeter, that's 25 centimeter. So by the way, this is string. This is actual distance, right? So I multiply 250 by 25 also. Okay, 6,250 kilometers. So a solution for part 2, the length of PQ. Our distance, the value of PQ will be 6,250 kilometers.